kind of lets us know where we're at with
Mhm.
everything.
Okay. Yeah, I was so thankful we did our class early last time because Thursday just ended up being horrible. And Friday, like the whole weekend was just like, I'd never want to get another root canal in my life. Let's see.
So do you have to go back again for this one some more?
I have to go back for the permanent crown. So, but that's it. So, okay. Does everyone have the quiz open?
Yep.
I'm almost there. You can go ahead and
We need
start.
to open up the normal probability applet. I'm trying to open it up in a different window so that. Okay. So it says, question 3 says, when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Mine's still opening. Say that again.
So when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is skewed, is right skewed? And so
it would be right skewed.
let me find the,
Because your sample population's not big enough to make it normal.
Do we do that this week?
In 6,
we're on lesson 6, right?
Yeah.
Okay, making sure I opened up the right quiz.
No, I know.
I
I
don't-
just don't remember going over that, but
it never said anything about a histogram. I
No,
think
it
that
didn't.
just stuck for me. But it's just saying it's the chart, it's the graph.
so is it right skewed then?
Yeah,
Yeah.
because
Okay.
it. Okay, so for when you were taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? I'm looking at how we.
How big's the population?
Pardon?
What's the sample size?
N equals 100.
So then it's going to make it normal because it's a large enough population
Yeah.
that it's going to be normal. I think this is where the central limit theorem comes in, maybe. That if you have a large enough sample size, your distribution is going to be normal.
Mm-hmm. Because the last one was low. It was only 5.
Right. So it would stay skewed. Does that make sense?
Yeah.
So question 5, when you were taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
So if it's normally distributed, then it's normal, right?
Yeah. Because it would be the same as,
Even though the sample size is small, it says it's normally distributed, which would make it normal. I think I read that somewhere.
Yeah.
I did retain something, maybe.
Okay. When you are taking a sample size of n equals 100, when the shape of the distribution of means histogram when the parent population is normally distributed.
Well, it would be normal anyway, but the population being 100
Would
makes
make
it
it more normal.
normal as well.
Okay. When would the distribution of means be normally distributed? And there's a couple different ones, like we can choose more than one. Data are drawn from a population that is normally distributed.
I think it would
Sorry,
be.
I have to answer that.
Oh,
Sorry.
it's okay. I think it's the first one, and this data drawn from a population that is normally distributed and the sample size is small because it says it's normally distributed. Data are drawn from a population that is normally distributed and the sample size is large because we already talked about that.
Mm-hmm.
Data are drawn from a population that is right skewed and the sample size is small. No. Data are drawn from a population that is right skewed and the sample size is large. Yes.
So I missed when you were reading the first one. I'm sorry.
Okay, I don't know if
First
your
two.
first is the same as mine. So the first one is data are drawn from a population that is normally distributed and the sample size is small. That
Yeah.
would be yes.
That's the same as mine. And then the second one is yes as well, when
Yes,
the sample
and-
size is large.
Yep. And then the third one is right skewed and sample size is small. No, because it says it's right skewed. And if the sample size
And
is
small.
large, then yes, but no. And then the last one is right skewed and the sample size is large. Yes.
So the first, second, and
first-
fourth.
Yep.
Yep.
Okay.
Oh. This is your baby, Linda. Which of the following gives the best explanation of the central limit theorem?
And I think it's the last one.
I think you're right. Because yeah. Become normal. Yep. Mm-hmm.
And yeah, because that matches with the answers on the answer sheets.
Mm-hmm.
Okay. All right, so here's where we get into the calculations that kind of made my head swim. Let X be a random variable with a population mean. I always forget what that U means. I also have to go look it up. Population equals 10 and population standard deviation. What does that O mean? I have it written down. I don't know
The
why.
O is the standard.
Oh, I think it just said it. Population standard deviation equals 6. Suppose a sample size of n equals 36 is drawn from this population. Oh my gosh, I'm gonna have to turn off my things. This lady from church is driving me crazy.
So the mean
Say
of the
that live.
distribution of sample means would be 10. Correct?
Right.
Okay, so how did we?
Because it's telling us in the question.
So what is the mean? So the population is 10. The population standard deviation is 6. Suppose the sample size of n equals 36 is drawn from this population. What is the mean of the distribution sample means?
So we have to use that equation.
Oh,
The-
it's not 10? We have to do the equation?
Where's that equation?
Oh, number 9 is 10. Yeah, I thought we
Yeah.
had moved on.
Oh, I'm sorry.
Oh,
Okay,
sorry.
so number 10, the standard deviation of the distribution of sample means. Oh, so we have to do the equation to find that out. Is that what you're
So we
saying?
have to do the O, which is the standard deviation. that
Which
right?
is 6.
Divided by the square
square
root
root.
of the population, which is 36.
Mm-hmm.
Can you repeat that one more time?
The equation is the O with the tail,
Uh-huh.
which is the standard deviation, right? Which is 6.
Yes, that's 6.
And then you divide it by the square root of n, which is the sample size 36. Or the
Well, that's
population.
over 6. No, square root of 36 isn't 6. I'm sorry. Or is
So
it?
is it
Yeah, it
1?
is.
Yeah, so it'd be 1.
That's what I came up with.
Okay. 11. Regardless of the distribution of the population, if the sample size is large, greater than 30, what would the shape distribution of the sample mean? Normal.
Read it one more time.
Regardless of the distribution of the population, if the sample size is large, what would the shape of the distribution of the sample mean?
Normal,
What
if it's large.
Yeah, that's what I'm thinking. Oh, what theorem, would that be the large of all numbers, justifies our last question?
I think it's the central limit theorem because it's talking about the shape.
Oh, you're right.
Oh, you're right. It is.
Okay.
That's the key words, the shape or the spread is the law of large numbers, is the spread. So if it's talking about the shape and how that's distributed, then it's going to be the central.
Awesome. That's it.
You want me to submit and see what happens?
Yeah.
Go for it.
I'll tell y'all. %.
Woohoo!
First.
Wow.
Wow, and for not really understanding it too well, we did okay.
Yeah. I
Ah.
wonder, we didn't need that little applet thing at all.
No, unless we were supposed to use it and we just didn't use it.
Yeah.
No, because I think that was the last lesson, and I don't think that carried over.
Yeah. I think maybe it's just up there now for
Yeah.
Oh, gosh.
whatever. Yeah.
Okay.
All right. Same time Thursday, ladies?
Yep.
Okay, I'll send you the invites.
All right.
All right.
Linda,
Thanks.
you're
Have a
getting
good
good at
week.
that.
Bye.
Bye.
Bye.